Hi and welcome. Thanks for joining us. If you enjoy the lesson today, I would ask you to come back and visit me from anywhere on the world through my great web portal, tutortalk.org. Connect with live teachers in dynamic, interactive online classrooms. Earn points while you learn to ace the SAT and other exams, or bring in your own homework problems. Now everyone can afford a tutor. We make learning fun.
So my name's Peter Gable, and I've been sending my son to see David Freeling at Insight Tutoring for over 2 years now, and David has really helped my son to learn concepts that he was having difficulty mastering in the larger group context. Sometimes homework and schoolwork can become a matter of struggle even among the most loving families, and to have a tutor like David really helps add someone to the family community that provides support in academic areas, sometimes in areas that we don't know about as parents, and just to have a place where that schoolwork can be done that isn't necessarily always within the home is a very good dynamic, very positive dynamic.
Welcome, my name is David Freeling, and I'm going to guide you through a very useful test prep strategy called testing the answer choices. It can be a great way on a standardized test like the SAT, GRE, GMAT, HSPT of obtaining the right answer when you're kind of stuck and don't know how to do a problem. The basic idea is there any way to use the answers they show you, work backwards, put them into the original question, and find your answer in a creative way by seeing which of the various choices is consistent with all the information you've been given. Okay, welcome back. We're developing strategies for testing the answer choices, a useful strategy for standardized exams like the SAT, GRE, and GMAT. The question at hand comes from the official SAT study guide, the Big Blue Book, page 597, number 12, if you have it at home. The question looks something like this. If x squared minus y squared equals 77 and x plus y equals 11, what is the value of x? Many students would be stumped by this question, but I'm going to show you a way you can get the right answer even if you don't know how to do it. So what you do is you might start right here with the easier looking part of the information they gave you. X plus y equals 11. I can wrap my head around that and think of various pairs of numbers that could potentially be answers for this question. Two numbers. Notice I keep picking values for x and y. That would make the sum of the two numbers 11, consistent with this equation. And what was tricky about this one is that on the SAT, sometimes you'll see questions without any choices given. And here's how we can generate some choices right off the bat to use for our testing the answer choices method. So once I have several possible choices for x and y developed, I'm going to take each pair and see if any of these pairs satisfy the other harder looking equation we've been given. For example, if the first row is correct, 11 squared minus 0 squared would have to equal 77. Type that in on your calculator and you'll get 121 minus 0, not equal to 77. Next, try 10 and 1. 10 squared is 100, minus 1 squared is 1. We would get 99, and again, that doesn't match the value we wanted, 77. Let's take a look at this row next. X is 9, y is 2. Let's try filling those into this equation, and I get 9 squared minus 2 squared. You can do it by hand or on the calculator. You'll get 81 minus 4, which does in fact happen to equal 77. The question was, what is the value of x? And we have it right here. X equals 9. Pretty easy by testing the answer choices. Because I'd like you to actually learn the math behind a lot of these problems, I'm going to explain that last one in a second way, and the key was using a common SAT and GRE factoring pattern called the difference of two squares. So we were given that x squared minus y squared equals 77, and according to this factoring pattern, you could factor x squared minus y squared as x plus y times x minus y. Now in the question you were also told that x plus y happened to equal 11. And so if you think about it, what number would x minus y have to equal? Well, 7 if you want the product to equal 77. Summarizing where we are so far in the problem, we have that x plus y equals 11 and that x minus y equals 7. In order to find x, we would now simply add the two whole equations together. X plus x is 2x, and here's the whole reason we're doing that. You may notice the y plus negative y eliminates or cancels out. On the right hand side, 11 plus 7 equals 18. And finally, dividing both sides by 2 would yield the same answer we had a few moments ago, x equals 9. So this is a challenging question that can best be solved using the testing the answer choices strategy. Let's take a look. A train rode from town X to town Y at 20 miles per hour and returned by the same route at 30 miles per hour. If the train's total traveling time was 10 hours, what was the one-way distance between the towns? And the choices look something like this: 90, 120, 150, 180, or 200. So, where to begin? Well, why don't we imagine for a moment that 150 was the right answer. You can often narrow down more quickly by testing answer choice C, the one in the middle. So let's pretend for a moment that 150 was the one-way distance between the towns. Now this question hinges around this formula, D equals R times T. Maybe you've seen it. Distance equals rate times time. Let's suppose for a moment that the one-way distance was 150, answer choice C, and on the way there we know that the rate was 20 miles per hour, but we didn't know the time. Well, you could solve quite easily for time by dividing both sides by 20. Do that on your calculator and you'll get time 7.5 hours as the time to town Y. Looking at the return trip at 30 miles per hour and still assuming that letter C, 150, was correct, my return time would be 150 divided by 30, or 5 hours. Now looking closely at what we've obtained, the total time would be 7.5 plus 5, and that would be 12.5 hours, but that does not match the 10 total traveling hours that they gave us in the question. Therefore, we know that 150 is incorrect, and furthermore, we can infer that a shorter distance would be needed to reduce the total traveling time, and that any longer distance, furthermore, would be incorrect. So now let's move on to either choice A or B. Suppose for a minute that 120 is the correct answer. And again, using the formula distance equals rate times time, let's assume that 120 answers the original question, what was the one-way distance? Well, they told me the rate going there, 20 miles per hour. Distance equals rate times time. Dividing both sides by 20 would yield 6 hours as the total time to get to town Y. Still assuming 120 is correct, let's figure out the return time. Traveling at 30 miles per hour, the total time would be 120 divided by 30, or 4 hours. A quick inspection of what we've obtained: 6 hours to get to town Y, 4 hours to return to town X, would yield a total traveling time of 6 plus 4, or 10 hours. Since this is the one answer choice that's consistent with the total time they gave us in the question, we know that 120 is in fact the correct answer.